Astronomers have observed what might be the perfect explosion, triggered by the merger of two very dense neutron stars. Researchers on Wednesday described for the first time the contours of the perfectly spherical explosion, called a kilonova. It occurs when neutron stars merge into a rapidly expanding fireball of luminous matter shortly before the combined entity collapsed to form a black hole. The two neutron stars, with a combined mass about 2.7 times that of our Sun, had orbited each other for billions of years before colliding at high speeds and exploding. This unfolded in a galaxy called NGC 4993, about 140 to 150 million light-years away from Earth in the direction of the constellation Hydra. The existence of kilonova explosions was proposed in 1974 and confirmed in 2013. But what they looked like was unknown until this one was detected in 2017 and studied intensively. It is a perfect explosion in several ways. It is beautiful, both aesthetically, in the simplicity of the shape, and its physical significance. Aesthetically, the colors the kilonova emits quite literally look like a sun except, of course, being a few 100 million times larger in surface area. Physically, this spherical explosion contains the extraordinary physics at the heart of this merger. The researchers had expected the explosion to perhaps look like a flattened disk, a colossal luminous cosmic pancake, possibly with a jet of material streaming out of it. To be honest, we are really going back to the drawing board with this, said astronomers in a statement. Given the extreme nature of the physical conditions, far more extreme than a nuclear explosion, for example, with densities greater than an atomic nucleus, temperatures of billions of degrees, and magnetic fields strong enough to distort the shapes of atoms, there may well be fundamental physics here that we don't understand yet. The kilonova was studied using the European Southern Observatory's Chile-based Very Large Telescope. The two neutron stars began their lives as massive normal stars in a two-star system called a binary. Each exploded and collapsed after running out of fuel, leaving behind a small and dense core about 20 kilometers in diameter but packing more mass than the Sun. Gradually, they drew nearer to each other, orbiting at a speedy clip. Each was stretched out and pulled apart in the final seconds before the merger because of the power of the other's gravitational field. Their inner parts collided at about 25% of the speed of light, creating the most intense magnetic fields in the universe. The explosion unleashed the luminosity of about 1 billion suns for a few days. The two briefly formed a single massive neutron star that then collapsed to form a black hole, an even denser object with gravity so fierce that not even light can escape. The outer parts of the neutron stars, meanwhile, were stretched into long streamers, with some material flung into space. During the process, the densities and temperatures were so intense that heavy elements were forged, including gold, platinum, arsenic, uranium, and iodine. Scientists are trying to find the reason behind the fundamentally astonishing, spherical shape of the explosion, calling it an exciting challenge for any theoreticians and numerical simulations. Thank you so much for watching this video. If you enjoyed it, please give it a thumbs up and consider subscribing to our channel for more content like this. Don't forget to hit the notification bell so you never miss an upload. We would also love to hear your thoughts and feedback, so please leave a comment below and let us know what you think. Thank you again for your support, and we'll see you in the next video.